A very good afternoon to all other participants in this workshop. Today I'm going to present a topic on climate change and coastal vulnerability. I'm Joyson. I'm working as a project scientist in National Center for Sustainable Coastal Management, which is coming under the Ministry of Environment, Forest and Climate Change. It is situated in Anna University campus, Chennai. So with this introduction, we can go into the presentation now on climate change and coastal vulnerability. So over the workshop, you have been all hearing about what is climate change, what are the impacts and those things. So this slide is just a brief introduction on about the climate change impacts and how it is affecting our environment. Especially we are living in India, we have tropical ecosystem. It is more vulnerable to climate change. And especially when we talk about the low latitude tropical and subtropical coastlines, we are very much susceptible to our climate change impacts. So especially talking about the coastal stretches, our coastal stretches are susceptible to these many threats: coastal erosion, coastal hazards, seawater inundation, and storm surge flooding, saltwater intrusion, and especially sea level rise, which is being more predicted in the future to be increased. So all these impacts have threatened our coastal infrastructures, properties, houses, agricultural lands, fields, and also many lives. When we talk about our coastline of India, so India ranks among fifth among the tropical countries in the world. So it has an about 8,100 kilometer coastal stretch along the mainland and the island territories. So we have 9 coastal states and 4 coastal union territories. So altogether it's coming under 8,100 kilometer coastal line. So in this, if you see the population, about 35% of the Indian population lives within the 100-kilometer stretch of our country's coastline. So we have two coasts, East Coast and West Coast. So East Coast is relatively more vulnerable than the West Coast. So today also we are seeing Nivar cyclone is passing along the eastern coast. So this stretch has more cyclone hits and more vulnerable features. So here on statistics I have provided, in the Bay of Bengal, the cyclones we receive, 58% are crossing the eastern coast, whereas in those forming in the Arabian Sea, only 25% are fall on the land. So this is showing how the East Coast and West Coast are vulnerable to the climate change. So you may have heard about the Indian Network on Climate Change Assessment, because during this workshop you may heard about this. So that INCCA, Indian Network on Climate Change Assessment, has designated 4 climate sensitive regions in India. So one is Himalayan region, another one is Northeastern region, third one is Western Ghats, and the fourth one is the entire coastal region. So this shows the sensitive nature of the coastal region to climate changes. So this is some of the projections of INCCAs. For example, the first image, which is a part of the Paradip in Odisha. So it shows how increase of 1 meter sea level rise, how the area will be inundated with the seawater. So if you see that map of the first figure, Paradip, so the red colors are showing the inundation levels. So 1 meter, if sea level is rise to 1 meter, so this much of land area will be underwater. So this is for Odisha, which is frequently exposed with the cyclones and storm surges. And when we talk about the West Coast, in the second image I have given the Kerala, the Kochi. So it is a region with backwaters, especially. So there, how a 1 meter sea level rise will have an impact. So there is red patches are going inward in the Kochi area. So third one is again the eastern coast, Nagapattinam, Tamil Nadu. So it has a flat topography. So with this topography, if 1 meter sea level rise means inundation is getting into deep inside. So these are the some of the projections. So which says that our coast is so much vulnerable to climate change impacts, and it is predicted that the mean sea level trend is about 1.3 millimeter per year. It is increasing. So with this impacts, we I understand. So what people are looking for are adaptation, climate change adaptation. So adapting to changing climate is becomes the central theme of most change action plans. So in India, we have National Action Plan to Climate Change (NAPCC). It has different submissions, in which one among them is National Coastal Mission. So the National Coastal Mission consider the significance of the coast and the vulnerability of it to the changing climate. They have targeted this mission. So under this mission, they wish to ensure the adaptive responses to be built appropriately so that the new threats of climate change should be dealt. So they have different objectives in which the coast should be preserved as well as it should be sustainably utilized. So in that they want to enhance the integrated coastal zone management and also reducing the coastal vulnerability, food security, and securing the livelihoods of the coastal communities. And further, they are urging to increase the carbon pools. For example, mangroves, salt marshes, seagrass beds are and carbon sequestration environment ecosystems. So they are getting depleted. So they are getting more and more degraded. So that should be developed, that should be managed, and that should be the cover should be increased. So these kind of things they are looking in the National Coastal Mission. So adaptation is one of the main theme of the coastal climate change action plans. So this is the National Coastal Mission, the conceptual framework. It has three important components. One is the assessment of coastal vulnerability. So that what I'm dealing now. Second one is the adaptation and the mitigation strategies. And the third one is the capacity building. So capacity building is a cross-cutting feature in this framework. So they have 5 key activities as a capacity building, which includes again the coastal vulnerability assessment, planning for the development, building the coastal communities' resiliences, and current conservation and capacity building. So when we see all these things, first thing comes is coastal vulnerability assessment. That too, scientific assessment of coastal vulnerability. It becomes a central part of interventions when we see for climate change adaptation. So with this, we can go into the details of the vulnerability. So we are all know about the Intergovernmental Panel on Climate Change. So IPCC third assessment report has defined what is vulnerability, which is given the first line. So vulnerability is the degree to which a system is susceptible to or unable to cope with adverse effects of climate change, including climate variability and extremes. So vulnerability is a degree of a system is getting affected. Actually, it is a function of 3 important determinants that is given as exposure, sensitivity, and adaptive capacity. So basically, vulnerability is a function of exposure, sensitivity, and adaptive capacity. So if we see each one by one, exposure it refers to the to what extent the system is exposed to the major climatic variation. Whereas the sensitive talks about how the system is getting affected either badly or positively to the climate variations. Whereas adaptive capacity refers to the ability of the system to cope with the climate change so that it can fight against or combat against the climate change impacts. So these 3 things are determining the vulnerability of a system. So if we this can be this is not only specific to coastal. In general, vulnerability is having these 3 components. So when we talk about coastal vulnerability, then we will talk about coastal exposure, coastal sensitivity, and coastal adaptive capacity. So this is how the vulnerability assessments are going on. So vulnerability, coastal vulnerability assessment. So we have learned what is vulnerability now. Now the next step is how to assess the vulnerability. Here, since my topic is on coastal, so it is coastal vulnerability assessment. So normally there are two approaches. One is top-down and bottom-up approach. So in top-down approach, it involves the analysis of climate change impacts with models, which advanced models and predictions and its impacts. So normally it will be in the range of higher level, that is global, national, and regional levels. Whereas bottom-up approach, it starts with the particular population, how the population is getting affected due to the climate change. So naturally, bottom-up approach will start from the local level, such as household, starting from household, village, communities like that. So these are the two important approaches. So in India, when we talk about the coastal vulnerability assessment, we have a lot of coastal vulnerability assessment based on the remote sensing and GIS methods. So most of these methods are talking about the physical vulnerability only. In other terms, I can say it is about the exposure, how the coasts are exposure. So using the remote sensing in these methods, physical vulnerability only we are getting more. Whereas social and economic factors are also should be included in that assessments, but it is largely ignored. And also in India's vulnerability studies are written macro pictures like the district level and state level. Whereas when we see at the administrative level, village is the basic unit, basic level. So our adaptation strategy should start from the village or panchayat level. So that's why here comes we have developed an framework for the coastal vulnerability assessment to address all these gaps. So our here I have provided a schematic of our coastal vulnerability assessment, what we have done. So basically it is a bottom up approach. As I said, it starts from the local level, from village to village, taluk, district, like that. The assessment will go, and the strategies and the interventions will go. So this is the schematic presentation of the coastal vulnerability assessment. We have 5 steps. In the coming slides, I will explain all these 5 in detail. So the 2 key roles of this framework is, one I already told, to assess the coastal vulnerability by including all the 3 determinants, that is exposure, sensitivity, and adaptive capacity in a spatial level, starts from village, taluk, state, and upgrade to country level. So using nationally comparable and credible data sets. And the second one is to quantify the vulnerability and also to analyze or assess what are the contributing factors, not only the vulnerability, what are the contributing factors which increases the vulnerability can be assessed from this framework. So with these two roles, this framework has its own context. So we have developed this framework and we piloted this with a study area, that is Sindhudurg district, which is in Maharashtra state. It is a coastal district. It has 3 coastal taluks. Devgarh, you can see the map down here. Devgarh, Malvan, and Vengula. These are the 3 coastal taluks. Whereas the coastal district has 8 taluks, but since our aim is coastal vulnerability, we focused our research on the coastal taluks. So here our sampling units are the villages and towns in the 3 coastal taluks. So totally we have 317 villages and towns in these 3 taluks. So one village is inhabited, so we neglect that village. So when we can see the condition of the study area, the Sindhudurg is predominantly an agriculture-based district, and the marine fisheries is also playing a major role. Tourism is emerging. And also when consider about the disaster and climate change impacts, it is frequently exposed with landslides, floods, and cyclones. So another prediction is saying that sea level rise in future will cause a loss of 1 kilometer square of area along the Sindhudurg district. So with this, climate change vulnerable feature, we focus this study area. As I said, the framework contains 5 steps. First one is the framework of coastal vulnerability assessment, which involves the indicators. So, what are the indicators we use to assess the coastal vulnerability, and how the data were arrived, and what are the data sources we used, and how we approach that. So, this is what I'm going to share in these few slides. So, as I said, there are 3 components of vulnerability: exposure, sensitivity, and adaptive capacity. So, these 3 determinants we focus to assessed in a way of an index form, so that quantifically we can say, okay, how is the exposure level, how is the sensitivity level, and how is the capacity level. So first one is exposure index. So it was determined using a spatial multi-hazard maps, which is developed by the INCOIS. That the next slide I will tell you. And then sensitivity and adaptivity capacity, and these are estimated using 23 indicators. So sensitivity has social and economic indicators, and also adaptive capacity will have social and economic indicators. So already we told that now. Most part of the coastal vulnerability assessments are ignoring this socio-economic parts. So we have given more emphasis on these indicators, like sensitivity indicators and adaptive capacity indicators. So each of these sensitivity and adaptive capacity will have social as well as economical indicators. So these indicators we collected through literature survey, expert consultation, and we did an opinion survey to give how much weightage to each of these indicators and how to arrive to index level. And it has been validated through various statistical methods like Cronbach's alpha. So how the internal consistency is among the index values, like that we have used statistical tests. So first part is an exposure component. So already I told that exposure component, we use the spatial multi-hazard map, which is prepared for the entire country by the ESSO INCOIS, Hyderabad. So we use that spatial multi-hazard map. So basically, it has these many parameters. So based on these parameters, like sea level trend of the area, shoreline change rate, elevation contours, extreme level, and the return period in 100 years. So these are the 4 parameters which they have used to spatially map the multi-hazards along the entire coast. So you can see this website for that. So it is not freely available. You can contact and you can share. These are some snapshots of the multi-hazard vulnerability maps. So, for example, the first one, which is in the Sindhudurg, Maharashtra district. So, the red areas in the map, the zoomed one is called the multi-hazard vulnerable zone. So, second one is a snapshot of a Kudalur, Pondicherry, and Viluppuram coastal stretch. So here, how the multi-hazard zone, see these red patches. So this is all based on the 4 parameters already told, like sea level trend, shoreline change rate. So it depends. So in Maharashtra, we have this much of level of multi-hazard vulnerability map, whereas in Pondicherry, Kudalur, and Viluppuram this much, and in Nellore district, so this much of coastal area is under multi-hazard vulnerable area. So these are some 3 snapshots of some areas I have collected from the publications. If you want, you can refer these publications: Mahendra et al. 2010, Mahendra et al. 2011. So we use this exposure. We estimated the exposure index for our Sindhudurg. This is the Sindhudurg area. So we get this map, and then we did the analysis. So that analysis, but how we did, I will tell later. Then second part, indicators, exposure is finished. Now sensitivity. So sensitivity, I already told sensitivity has social and economic sensitivity. So social has 6 indicators, economic sensitive have 5 indicators. So totally we have 11 indicators. So the details of the 11 indicators are here. So most of these are uh, uh, you can see sensitivity social. They have 6 indicators. For example, first one is, I'm not going detail into that. Just for a snap few things only I can tell. First one is small and marginal farmers. So here it will take the percentage of small and marginal farmers in relation to the total zone area in the village. So the data source for that is agriculture census. It is easily available. You can download it from the net also. So here it is a sensitivity component. So what we are here saying now, small and marginal farmers, if the proportion is higher, they are more sensitive than the large farmers. So, and similarly, we can see the agricultural laborers. So we take the measurement proportion of agricultural laborers among the total workers population. So this we got it from the census data. In later, I will show you Excel where how the data is compiled and how the analysis was done. So here, in relation to the sensitivity, so greater the proportion of agricultural laborers, it is called greater the dependence on agriculture, so greater the risk. So like that, the sensitivity social component has been included. So we have totally 6 parameters for the sensitivity social. So SC/ST population, last one is there. Population density. So higher the density, higher the sensitivity. It's like that. So these are the different sources, and these are the extent of the data. For example, small farmers, it is percentage, so it normally ranges from 0 to 100% like that. So in most cases, it is percentage. In some cases, we have population density. It may vary from any number. So we have used this small number 1 to maximum what is observed. It's like that. And next is sensitivity economic indicators. We have another 5 parameters: net zone area, annual rainfall, dependence, distance to nearest town, distance to nearest hospital. So distance to nearest town, distance to nearest hospital are most important parameters, because when vulnerability comes, if they are close to the hospital or medical facilities, then they are less vulnerable than the those who are available from in a distant area. So this is the parameters we have used. And for example, annual rainfall. So higher the annual rainfall, productivity will be there, but less rainfall means higher sensitivity. So in these indicators, some are directly related to the sensitivity and some are inversely related to the sensitivity. For example, annual rainfall is inversely related to sensitivity, in which higher rainfall means less sensitivity, less rainfall means higher sensitivity, like that. And the third one is the adaptive capacity component. Here also we have 2 aspects: adaptive capacity, sensitive, social, and economic characters. So social indicators are 6, economic indicators are 6. So totally 12 indicators for this adaptive capacity. So finally we have 23 indicators for this sensitivity and adaptive capacity component. So these are the indicators. So this is adaptive capacity social indicators. So in adaptive capacity social indicators, we have 6 indicators. So here education status, what is the literacy level, household amenities, how the households have access to the drinking water, sanitation, everything like this. So here, if we talk about educational status, higher the education, adaptive capacity will be higher. So that is the logic. So most of the data are derived from the our census 2011 data only, which is freely available for at village level also. So these are 6 parameters, 6 indicators for the adaptive capacity, social parameter, and next is economic aspects of the adaptive capacity. Again, we have a 6 indicators. So these are the indicators we have used, and the data sets for that indicators are mostly census, livestock census, agriculture census, all are and Central Groundwater Board, their reports, a National Family Health Mission, So these are the data sources. So these are the 23 indicators we have given here. See, SMF means small and marginal farmers, which is a social sensitivity indicator. So it is coming like that. Well, you see this pie, the all the indicators have a different weightages. So basically, when we add all these social indicators of sensitivity, it amounts to 100%, but it is a different weightage. So that how each indicator is um, related, or how it is contributing to the overall sensitivity of that thing. So these are the weightages. So in the right side we have the so many weightages. For example, social sensitivity has 1, 2, 3, 4, 5, 6 indicators, and their weightage is this. So this weightage we arrived through an expert consultation and statistical analysis. So these are the different weightages. For example, dependence on natural resource indicator has a weightage of 28.4% to the sensitivity, economic sensitivity. Okay, so all these indicators will assess the sensitivity, and these indicators will assess the economic sensitivity. These are all social adaptive capacity, and then these are all the economic adaptive capacity. After finding these indices, social sensitivity and economic sensitivity averages sensitivity index, and the social adaptive capacity index and economic adaptive capacity index average will be adaptive capacity index. So finally, we will take the average of the index values. So when we talk about the data ranges, our approach, when we talk about the data ranges, already I showed that the data has been in different ranges. For example, one SMF, that is small and marginal farmers, that range 0 to 100%. Whereas population density, that data range will from 1 to any number. So they have different ranges. But when we arrive to a common indicator, we have to normalize everything. So we normalize the data ranges using this normalization method. It is called min-max normalization. So here this is the actual value minus the minimum observed value in this range divided by the maximum minus minimum observed value. So that will give you a normalized value. The normalized value will be between 0 to 1. So we have converted all the data into 0 to 1. So depend upon the relation of the indicator to the sensitivity and adaptive capacity, we use two equations for this. First one is for directly related one, equation 1. Second one is inversely related equation. So I will show you on Excel so that 1 minute, the Excel is loading. Can you all see the Excel?
Sir,
Sir?
you're still seeing the presentation. We can see the Excel file.
Oh, 1 minute. Now?
You're able to see it, yeah.
Yeah. So, okay. So this is the data in the Excel. So it may look large, but basically,
It stopped presenting. We can't see it anymore. We briefly saw it, but we can't see it anymore.
1 minute. Now?
Visible. Now it is visible.
Now okay, na? Okay.
Yeah, now it's okay.
Okay.
Thank you. So this is the Excel. So it looks large because there are village wise data is there. So totally we have 319 entries. So this is the district. District is Sindhudurg. So it will come Sindhudurg only. Then taluk, already I told three taluks. They've got taluk and their villages are here. Then down, if you go Malvan taluk and the villages, and Vengula taluk and the villages. So when we talk about the first indicator is in sensitivity social. This is sensitivity index in that social component. So already I told what we have considered. We have considered the small marginal farmers, marginal farmers and small marginal farmers, and this is the total net sown area. So we calculated the proportion of the marginal farmers in the total net sown area, which is 22.5% for this village, and small farmers it is this percentage. So adding these will come 39%. So these two 39%. So this is directly related to the sensitivity, because I said small and marginal farmers, if they are higher proportion means sensitivity will be higher. So here I use the min max equation 1 direct relation. So which is this value, that is this value divided minus the minimum value which is observed here. So minimum observed is 39 only, divided by maximum minus minimum. So sorry, here minimum maximum is 0 and 100. Sorry, because percentage only na. So minimum value will be 0, maximum will be 100. So we will get the 0.39%. So whereas we have already showed the weightages for this indicator. So it is in that PPT I was showed the weightages for that. So for this indicator, through expert consultation, the weightage is 10% of that. So we take not the take actual value, 10% of this value. So 0.043 comes 10% of the 0.39. So this is how. So this score will be added to the sensitivity like that for each indicator. For example, for Fisher population, like that, we will estimate the index with minimum min max normalization, and then using the weightage for this indicator. This is the 15.43 is the weightage. So we will take 15.43% of this value. So like that for all the six indicators in the social, we will do that, and then finally we will add all these weighted scores into this. So if you see, it will range between the index value will it is now sensitivity social component, which is 0.14 for this village. So we can say this is have a very less sensitivity, whereas other villages have different values. So this is how we did the analysis. So right now I'm going back to PPT. 1 minute. PPT you can see now.
We can say it.
Yes, thank you. Okay. So this is the how we did in the Excel and how we arrived the index using these weightages and these normalization methods. So next, I already told that. Next, so these are all our indicators. So we have 23 indicators for sensitivity and adaptive capacity, and how the weightages we have given, what are the data sets and sources, and how we approach that. So with this, we will get an village level sensitivity index and adaptive capacity index. So, but we still lack vulnerability. We need exposure index. So that I'm going to deal now. So this is second one is the cumulative vulnerability map. So cumulative vulnerability includes exposure, sensitivity, and adaptive capacity. So already I told we use the uh, spatial multi-hazard map of Incois. So already I shared the map of that Sindhudurg district MHVL. So in that we have drawn further lines like buffer lines, 500 meter, 1000 meter, 1000 to 1500 meter. So these are all segregated into different zones. So that I will explain now. See here, I can show you. So this is the MHVM zone. So the red one is the multi-hazard map. I have zoomed to a particular location here. So here, so the main the red color patches zone of the village area we will determine from the map, and then we drawn four different lines. That is 500-meter from this line. This is the zone, zone 2. Then 1000 meters from this line, which is zone 3. Then 1500 meters from this zone, it is zone 4, and finally above 1500. So we have five zones. Zone 1 is the original multi-hazard vulnerability map. So for a particular village, how much it covers, that area will be calculated, and four different buffers were drawn. So for example, here I'm showing you one village. Here it is Hardy village. This is Hardy village. So Hardy village boundary is like this. These orange lines you can see now. So in that Hardy village, so after drawing these lines, we come to know how much area are occupied in each of these region. For example, zone 1, which is directly under the MHVM zone, it is 153 hectare. Then from that 500-meter buffer line, there is 117 hectares are lying. So like that, the total 561 hectare of that village has these as dispersed in different zones of this. So we calculate the percentage of that, and we have given a weightage of 1 for zone 1 because it is the most vulnerable one, the directly impacted one area. So it has highest weightage, that we give as 1. Then zone 2, which is slightly away from that 500-meter away from the main hazard line, so it is having a less weightage relatively. So 0.75, 0.5, 0.25, and finally 0. So these weightage we applied, then this percentage cover and this weightage, if we multiply and add, we will get an value which is 0.56. So this value will range from definitely 0 to 1. So after so we segregated the 0 to 1 into 5 different classes, which is 0 to 0.2, which will show the index exposure index is very low, 0.21 to zero point 0.4 low, 0.41 to zero point 0.6 moderate, 0.6 to zero point 0.8 high, zero point 0.8 to 1 very high. So depending upon the index value, for this village it is coming 0.56, so it lies in the middle range, so it is moderate. So we can say this village Hardy is having a moderate level of exposure index. So like that, we have calculated the exposure index for all other villages and towns in the map. So I will show you that Excel so that you can get an idea. Wait, I will share it now. So sorry, I can't able to share it. Sorry, I can't able to share it. Now you can see that PPT, no?
We can see the PPT.
Yes, yes. Thank you. So, so, so this is how we calculate the exposure index for a village. So here is that uh, in the right side bottom we have the image that how the exposure different zones, how much percentage of the area are distributed. So, for example, in Devgarh, 7% of the total land area is under the zone 1, which is the main multi-hazard vulnerability under the multi-hazard vulnerable hazard map, and 19% are from the 500-meter buffer, like that. So this is the dispersion of the taluk wise and the overall Sindhudurg wise. So this is how we calculated the exposure index for the villages. And and one more parameter we have done is, so in social and sensitivity and adaptive capacity, already we did village wise how we did that one, we already explained from here, and I showed you in some example. Whereas after that, I already told that this will be scale up. This can be scale up to taluk level, district level, state level, like that. So this is the equation we followed for the after estimating the village level sensitivity and adaptive capacity. After that level is taluk level. So for that taluk level, we use this formula. So it is nothing but the sensitivity of the villages in that particular taluk into the proportion of the population of the particular village in that. So we multiplied that and then added that. So this will give the sensitivity index of a taluk level, and also using from the taluk, after determining the taluk level sensitivity index, the SI taluk level, we used again this for the district level estimation. So whereas the taluk population proportion is multiplied with the sensitivity index and adaptive capacity index, and then they are added up. So this is how we estimated the village level, taluk level, and district level. Then finally we have the cumulative vulnerability map. So finally now we have estimated exposure index, sensitivity index, and the adaptive capacity index. So this cumulative vulnerability index, so already told, vulnerability is a function of exposure, sensitivity, and adaptive capacity. Whereas exposure and sensitivity has a positive relation, whereas adaptive capacity will have a negative relation. So because if we have adaptive capacity more, then we are our vulnerable level is level. Whereas if we have a higher sensitivity level, our vulnerability level is high. So this is the relation. So we derived a formula to determine the cumulative vulnerability index, that is exposure index into sensitivity index divided by the adaptive capacity index. So for each village and town, we have this index, three indices. So exposure index and the sensitivity index are multiplied divided by the adaptive capacity index, and they were mapped. So I will show how we did the mapping in QGIS, so that you can also have some how to do the mapping of that. So it is done in QGIS. So I will share it on. I think you can see this window.
Yes, sir, it's loading. Yeah, we can see it doing now.
Yeah, yeah. So this is the QGIS. QGIS is quantum GIS. Basically, mapping and GIS tools are available. ArcGIS, QGIS, you may heard about that. I choose QGIS because it is open software. It's a user-friendly one, so you can use it for your mapping related work using this software. So now I will show you how that values have been mapped into a map level. So for that, so this is, you have to click project and give new. So if you click on this, this will come. So first we have to add the map. So first our location is Sindhudurg. So already I have a shape file of that study area. So I'm going to add that. So first one is click on the layer, and you can give add layer. So in that, so many layers are there. So ours is a shape file. So it is a basically lines, polygons, parts containing files. So it is a vector layer. Raster layer means imageries, photos are raster layer. So right now I'm going to use the vector layer. So click add vector layer. So it will show this one. We have to choose the file name. So here it is given file, and then here already is there. I will read this. Let us just click on this three windows so that it will open the your local files. So in that I have already have the shape file. See, Sindhudurg village shape file .shp. So this we can click and give open. So it will get open, and we have to add this. One minute, it's loading. Yeah, I think it's added three times. Okay, so this is the Sindhudurg three taluks, Devghat, Malvan, and Vengurla. These are the villages. So all these polygons are talking about the villages. Now what I have done is we estimated already the index value for all these villages. For example, if you want to see this file, right click on this file and give open attribute table. It will show the contents of that shape file. So basically it contains what is the state name, district name, what is the GP, IP is that taluk name. So these are some codes which was prepared while compiling this GIS layer. So here we have the village name. So what I did now, so this village name, I used this village column and I made an Excel, and I fill the village name side by it, and then I enter all the um, estimated indices for. So I will show that Excel for you so that you can understand. Only. So now you can see another Excel. No? Can you able to see the Excel?
Sir,
Excel is showing.
yeah, Excel is visible, sir. Yes.
Yeah. Okay. So again, so these are the parameters which I copied from that table. So this is the village name in that shape file. So what I did now, I have used the same name here and compile the data. For example, as I explained how the I mean exposure index, sensitivity index, adaptive, these are all now entered here against the village's name. So, and another I have given a class. So for example, already told, so our index value, all index value range from 0 to 1, which is segregated into 5 categories. 0 to 0.2 is very low, 0.2 to 0.4 low, like that. So here EA is high because 0.75 exposure index is 0.75 for this village. So it lies in the range 0.6 to 0.8. So it is high. So like that, I have given the class for that. So like that, for exposure index, I have given the category, sensitive index, adaptive capacity index, and cumulative vulnerabilities. So this Excel, I have made it. So this is the Excel of that. So we have one thing is we have to make this Excel and we have to save this as a CSV file, not as a XLS file. We have to save it as a CSV file. So that file we have to upload there. So right now I'm coming again to that QGIS. So now you can see the QGIS platform. No? So we have that village layer. Now I'm going to add that Excel file. So again, I'm going to go to layer and go to add layer. In that, we have to go to the add delimited text layer. So this is for uploading the Excel. So we have to click on this add delimited text layer. So after that, we have to choose the file name. File name is, so I, this is my, the Excel I showed, no, that file. It is a CSV file, the CSV format. So we have to open that. So it will get open and we have to give add and close. So now this layer and the Excel are both are added. Now we have to click on that, right click, properties. We have to do one more thing. We have to join the layers because these are two layers. One is CSV file, that is Excel file. Another one is a save file. So these two should be merged so that we can map the values. So when we click on that properties, it will show these parameters. I mean these menus. In that, go to join. So we have to join that. So after clicking join, down there is a plus symbol. Add new join down. You have to give add new join. So now it will show our file. This is our Excel file. This is my CSV file name, Sindhur mapping data class. In that, I have to join the field. So in that, I have given the village's name in a separate column, which I marked in two orange colors. So one orange color is from this CSV file. So we have to click this, and this should be matched exactly with the village name in the shape file. So shape file, this column contains the village name. So this two we got to. So basically this exercise will cross check the names in both these files and it will join. So I'm clicking OK. So it shows that join layer. Now it comes like this. Now click apply. Apply and OK. Now again, now it's the file is ready. Now we have to mapping. So again, I'm going to properties. So already we did join. So it is now join. Now go to the symbology. So in the symbology, there are symbols, single symbols, categorize, graduated. So I'm clicking categorize. When I click categorize, it will ask on what value basis you want to categorize. So when I click down, so it will show the columns, headings of the Excel. So straight away, I already given the index EA index value, this one, and another column of the index value is converted into 5 categories: high, very high, low, like that. So that column contains here. So I'm now mapping the exposure index class. So I have to select that attribute, that column, and then give classify. So when you give classify, automatically there are 5 categories. So that 5 categories will be showing. So you can change that category. For example, if we say very high, I want to look in the map. Very high exposure means red color, like that. So I am choosing red color. Okay, for that very high. Then high will have somewhat lighter than red. Double click on that. You can see the colors and you can change the color. Can I give orange? I will give. Then moderate. Moderate, I can give some yellow. So you can choose your own colors. Basically, high to low means red to green. We can choose. Then low, we can have some light colors. So these colors you can choose based upon the your logical explanations. So very low, it says thicker. So this is not needed. So we can click on this and we can delete, and we can give apply. So when I click apply and OK, so your map will be now colored, and it shows that how the exposure index of villages are there. For example, we this in the coastline we have see a lot of orange colors. So these are high. So we can say that in coastal areas we have high exposure to villages, even though there are some few villages have moderate. So like that we can map the data. So using this QGIS. So I already told ArcGIS they are using, but QGIS it is more user friendly. You can use it for this and other for your other research purposes also. So if you want to map again, uh, instead of exposure index, if you want to map sensitivity, you can select the sensitivity class, and then like that you can go. Let us see the cumulative vulnerability. So I am clicking that and I'm classifying it. It is showing already there is a classification. You can remodify it. Okay. So colors I will change later, but now we will see how it looks. So this is the cumulative vulnerability. So again, cumulative vulnerability, coastal regions are have red color, high. So this is how we can map the determine indices into for your presentations. Okay, with this I am going back to PPT. So this is how the cumulative vulnerability index or exposure index, sensitive index, and adaptive capacity can be mapped using the QGIS software. You can see the PPT now. No?
You can see the PPT.
Yeah. Okay. So this is the how the cumulative vulnerability for taluk wise, how the number of villages are in different categories. For example, in Sindhudurg, there are 317 villages in town, in which 129 villages are very low, having very low vulnerability, whereas 33 villages are very high vulnerability. In terms of percentage, it is showing 10% of the administrative units are very high. Already we saw along the coastline, they are all, I mean, concentrated. So this kind of statistics we can derive from the value. So this is the parameter wise. Already told we have 23 indicators. For sensitivity, we have two, social and economic. So social are these, economic indicators are these, and for adaptive capacity again social and economic aspects. So these are our, the index values are mapped here. Here we can see how the indicators are dispersed. For example, in terms of adaptive capacity, so economic dependency ratio is very high. That's why this box plot is on the higher end, whereas access to market is very low. So we can find the what are the indicators. It is overall indicator for Devgad. This is the statistics for Malvan, how it is dispersed, for Vengula and overall Sindur, how it is dispersed. So in such a way, the index value can be mapped and presented here, and we can see how the parameters are varying and what parameters are contributing, what parameters are contributing adaptive capacity we can find. So this is what I did. So this is now all the four indices we have given. So third one we are closing now. Third one is socio-economic vulnerability. So here we only took the social and the adaptive sensitivity and adaptive parameters, so that only the in socio-economic point of view how the vulnerability was uh, can be done. So basically, if you see this map, for example, sensitivity, if you see there is no dispersion. I mean, the values are more or less lie between 0.21, 0.4 to 0.4 to 0.6. And similarly here also this. So this is because of the our data is on the national scale. So what we did here now, so to have a local specific intervention, for example, within a district, within the Sindhudurg district, how which villages should be considered, which village is socioeconomically vulnerable. To find out that, we use this index. SEVI is again nothing but socioeconomic sensitivity already we derived that divided by 1 plus socioeconomic adaptive capacity index. So we use this values and then we map it. So here we can see how the dispersions are clearly visible. Now here we have not much variations, but when we do this analysis and do this rescaling and this, we can able to extract a more variation in terms of sensitivity, adaptive capacity, and the overall socioeconomic vulnerability. So this is done in order to have a local specific intervention. So this is how we did. So this is how the dispersion, how again the index values range from 0 to 1. So it is categorized into 5, very low, low, moderate, high, very high. And what are the numbers, the proportion of the villages and towns in each of the category we can see here. So after this, we have used this sensitivity and adaptive capacity as a decision matrix tool so as to identify the socioeconomically vulnerable areas. So here what we did now, we took the sensitivity. This is the Devghat villages. So we took the sensitivity index on the x-axis that range from 0 to 1, and the adaptive capacity on the y-axis 0 to 1. So the data, the villages data were plotted on this scatter plot. So here the each circle represents the village or town, and the size of the circle it represents the population density of the village or town. For example, this green color one in Devghat is the highest one. That's why it is having a huge bubble, and the color is the SEVI, that is socioeconomic vulnerability index value, and the position will tell which villages are vulnerable. And for example, here in this, the first quadrant will have a least vulnerable because here we have sensitivity value 0 to 5, 0 to 5, and the adaptive capacity will be 0.5 to 1. So higher side, adaptive capacity will be higher side, sensitivity will be in the lower side. So these are all least vulnerable compound villages. Whereas this quadrant will have highly vulnerable villages because of the dispersion of the index value. Because here sensitivity is from 0.5 to 1, so higher side, whereas adaptive capacity is lower side, 0 to 0.5. So the quadrant, the villages which are coming here will be can be designated as highly socially vulnerable villages. So this decision matrix tool will tell more detail about the socioeconomic vulnerability. So as a whole, if we see, Sindhudurg has a low vulnerability, but socioeconomically, when we analyze with this tool, we get that about 43% of the villages in Sindhudurg are highly vulnerable. So adding this one and this one and this one, we will get this much number. So this decision tool will be matrix is used to identify the highly vulnerable spatial units, villages or towns in that area. So finally, this can be if we take one village, for example, in this matrix I already told this quadrant, that is third quadrant. First quadrant is this, second, third, fourth. In this third quadrant are the villages or units having highly vulnerable characteristics. So we have zoomed that village and we have plotted all the parameters. Socioeconomic parameters, already we told 23 indicators. No? We can see what are the indicators. For example, red ones are, we can say that they are the drivers. So they are the driving the sensitivity, whereas green in this sensitivity are the buffers. And also in the adaptive capacity indicators, which are all red ones are the drivers for the low adaptive capacity, whereas green ones are the buffers for the higher adaptive capacity. So using this method, we can see for a particular village, we can see how is the characteristics and what indicators. So when we talk about climate change, what kind of adaptation, in what areas we can adapt, we can build resilience, we can determine from this one. So this final table below is overall picture for the Sindhudurg. So in Sindhudurg, we using this analysis, we find that the key drivers or the indicators for high sensitivity are distance to nearest town, distance to nearest hospital, which means most of the villages don't have this hospital or are they are way away from the nearest towns, and there have high proportion of small and marginal farmers. And buffers for reducing the sensitivity. So these are some good characters they have, which reduces the vulnerability. For example, population density in most areas, population density is very less, and SCST population is very less, and malnutrition condition is very less. So these are all some of the indicators which strengthen, which reduces the sensitivity. And like that, for a low adaptive capacity, what are the drivers? So net irrigation area, transport and communication. These are the indicators. What are the buffers to enhance the adaptive capacity? So final part of this will give and status of for a village, for a district, for a taluk, we can find it out. So using this framework, so we have done this coastal vulnerability assessment. That's all.